Every mass extinction in Earth's history shares one unsettling detail. The trigger never actually came from Earth. One of them wiped out roughly 3/4 of all species alive at the time, and the strike that started it lasted only seconds. Space has hit us, frozen us, and irradiated us since then, and by the end you'll know exactly how close the worst version of that has come to happening again. We're ranking every extinction-level event space has thrown at this planet, worst to worst, ending with a threat that could kill everything without a single rock ever landing. Start with the one everyone knows, an asteroid roughly the size of a mountain slamming into what's now the Gulf of Mexico. An impact that detonated with the force of billions of nuclear bombs, set forests ablaze on the far side of the planet before the blast wave even got there. It also triggered earthquakes and tsunamis that reshaped coastlines an entire ocean away. Forget the fire, dust did the killing, blacking out the sun and starving the food chain from below. 3 out of every 4 species on Earth, including every non-avian dinosaur, simply ran out of world. Impact winter dropped global temperatures for years, maybe over a decade, before the food web even partially recovered. One rock, one afternoon, 250 million years of dinosaur rule erased before sunset. Only one asteroid ever threatened Earth. Space has tried this at least half a dozen times. 12,900 years ago, Earth was thawing out of an ice age, and then, abruptly, it wasn't. Temperatures crashed back into a deep freeze in what may have been just a few decades, a climate U-turn scientists still argue about. One theory, a comet shattered over the ice sheets, choking the sky and maybe ending a culture. The proof, a hairline seam of platinum group metal buried worldwide, the exact fingerprint impacts leave. It's still debated, the evidence is scattered, not conclusive, but if it happened, it proves something scarier. A hit doesn't have to be dinosaur-sized to reroute human history. Right then, mammoths and saber-toothed cats vanished across North America, timing too clean to ignore, crater or not. Smaller object, contested evidence, and it may have still frozen a hemisphere. Picture what a confirmed hit could do. Rewind further to 440 million years ago, the second worst extinction Earth has ever survived. It ranks among the top 5 worst die-offs ever recorded, right up there with the one that killed the dinosaurs. The leading hypothesis, a massive star, thousands of light years away, collapsed and burst, firing a beam of gamma rays that happened to be aimed at Earth. A burst like that can release more energy in 10 seconds than the sun produces across its entire lifetime. And it doesn't need to hit the planet directly. It just needs to hit the sky, shredding the ozone layer and flooding the surface with ultraviolet light. No crater here, just radioactive isotopes locked in ancient rock. A scar gamma rays leave in an atmosphere. Roughly 85% of marine species disappeared, with no crater, no dust cloud, and no warning. Here's the one that isn't ancient history. It's a live risk, aimed at civilization right now, every single day. In 1859, a solar storm called the Carrington event hit Earth so hard that telegraph wires sparked and caught fire on their own. That was a world with almost no electronics. Today, a storm that size would fry transformers, satellites, and GPS. Grid transformers can't absorb a geomagnetic surge, and replacements take months to even build. Modern civilization runs on a power grid the sun could, on a bad day, casually switch off. In 2012, the sun fired a Carrington-class blast straight across Earth's orbit. We just weren't there yet. A modern Carrington storm carries $1 trillion price tag before you even count the dead satellites. Missed by 9 days. That's the entire margin between a historical curiosity and a blackout that could take years to fully repair. Roll the dice each decade. Roughly 1 in 10 odds Earth takes a Carrington-class hit. Now combine the first 2 threats. What if an impact didn't just kill directly, but pulled the trigger on something even bigger underground? 252 million years ago, the Permian extinction gutted 9 in 10 species, the worst ever. Compare that 90% to the dinosaur killer's 75, and the Great Dying still wins, by a wide margin. It lines up with monstrous Siberian volcanism, and some researchers think an impact lit the fuse. Contested, yes, timing's fuzzy. But if one strike can crack a planet's crust, that's a chain reaction. One trigger, two extinction mechanisms stacked together. And this isn't even the worst entry yet. Not every mass extinction needed a rock at all. Some, like the Triassic, came from volcanism alone. Space doesn't have to hit you to end you. Step back for a second, because there's a thread running through every single one of these. An impact blacks out the sun. A burst shreds ozone. A storm fries the grid. Same thin margin every time. That margin is a few kilometers of atmosphere, a magnetic field a few hundred miles up, and roughly 93 million miles of empty space between us and the sun. Even Earth's magnetic field has flipped before, weakening its protection for centuries at a stretch. Another gap the universe knows how to exploit. Every extinction on this list happened because that margin got tested just a little. So here's the real question. What happens when something tests it completely? Remember that gamma-ray burst that may have ended the Ordovician world. That one came from thousands of light years away. Same weapon, same physics, except now it's firing from next door. This is the worst-case scenario astronomers actually study, a supernova or gamma-ray burst going off within about 30 light-years of Earth. 30 light-years sounds distant. In galactic terms, that's the house next door, close to a few dozen of the stars visible tonight. No star that close is currently expected to explode. This is a hypothesis about physics, not a prediction about tonight's sky, but it has almost certainly happened before in Earth's 4.5 billion-year history. A supernova that close would blast Earth with gamma rays and cosmic rays for months, not seconds. Those rays would tear straight through the ozone layer, the only thing standing between the sun's ultraviolet light and every living cell on the surface. Strip the ozone and UV radiation spikes for years, enough to shred DNA in plankton plants, anything exposed. Plankton is where the ocean food chain starts. Kill enough of it, and everything above, fish, birds, whales, starves in a chain reaction that takes years to finish. The supernova doesn't need to touch Earth directly. It just needs to switch off our sunscreen from 30 light-years away. A dip in ocean life 2.6 million years ago lines up with iron-60 in the seafloor, an isotope only dying stars forge. That wasn't a direct hit, just fallout drifting in from a supernova hundreds of light-years off. Now scale it up. 30 light-years away wouldn't dust the seafloor, it would strip the shield entirely. Some scientists blame the late Devonian extinction, 359 million years back, on this exact mechanism. Ozone collapse, no impact needed. No crater has ever been found for it, which is exactly what you'd expect if the killer never touched the ground at all. Ocean life would take the worst of it. Ultraviolet light penetrates surprisingly deep into clear water, right through where plankton actually lives. On land, crops and forests would face that same radiation spike. At the exact moment the ocean's food supply starts collapsing, there'd be no shelter to build and no evacuation route. The entire biosphere would be exposed everywhere for years. This theorized cause gives the least warning of anything on this list. Light from the exploding star reaches Earth at the same instant the radiation does. It's part of why some scientists treat the search for nearby supernova candidates as a form of long-range weather forecasting for the entire species. So here's the answer to the question this video opened with. The deadliest thing in Earth's history was never really the rock. Its proximity to anything violent enough, close enough. An asteroid is just the version of that threat small enough to hit us with any regularity. A nearby supernova is the version big enough that it never has to. None of this is a countdown. No known star near Earth is due to explode, and the next dinosaur killer-sized asteroid isn't on anyone's calendar. What it is a reminder that Earth's habitability was never guaranteed. It's a run of good luck against a universe that occasionally reaches in. That's also why we track near-Earth asteroids, why solar observatories watch the sun every second, and why most of this list ended up a near miss instead of a body count. Somewhere right now, an automated system is scanning the sky specifically, so this video doesn't need a sequel called The One That Actually Got Us. If a gamma-ray burst really can sterilize a planet from 30 light-years out, the obvious next question is, how many stars close enough to do that are actually out there? That's next. Cosmic Scale ranks the real nearby stars capable of ending life on Earth. Subscribe so you don't miss it.